20 minutes before class to get my Zen in has thrown completely. So hopefully I can get it back now. Well, after you, I just have to teach AI itself. I don't have to think for that. This is the only lesson I have to think for. We are going to look at the distance formula today. We're not going to do the warm-up. So this is going to be based on Pythagoras' theorem. And the basic idea is how can we calculate the distance between 2 points? So the basic idea is we're going to have a coordinate axis. We're going to be given 2 points like this at some point in the question. What is the distance between those 2 points? Now, what makes it quite easy to work with is when we put 2 points on the coordinate axis, what we're using all the time in this analytic geometry is Pythagoras' theorem. This is because the x-axis is at right angles to the y-axis. So we can always draw right-angled triangles on the coordinate plane all over the place. So we are after this distance there. What we do is we make a right-angled triangle like this. Now this distance along the base is the change in x, and this distance on the y-axis will be the change in y. That will give you the 2 legs of a right-angled triangle. If you have the 2 legs of a right-angled triangle, you can find the hypotenuse, and that will be the distance that we're trying to calculate. This is going to work wherever we spin this triangle all over the place, because any line goes between 2 points. You can come straight down the y-axis, straight across the x-axis, and you make a right-angled triangle. So, what we want to do for that one is if we have 2 points, A and B, we need to find what is the change in the x values, like we do with slope. So we're going to find the change in the x values, like here, and we're going to find the change in the y values. The change in the x values is the length of the base. The change in the y values is the length of the height here. So we can use the square of these two to find the square of that. Square rooting that will give us the length that we're after. So we come up with very simple rearrangement of Pythagoras' theorem given here. Let's use it in a basic question to see how it works. So what we need to do is we need to find the distance between these 2 points. So the distance is going to be given by the distance formula. Just write the formula up. The distance is equal to the square root of the change in x squared plus the change in y squared. What's the change in x here on these ones? 4. So we need the square root of 4 squared. What's the change in y? No.
6.
Yeah. The actual change is minus 6. The actual change there, if we're using it for slope, it's minus 6. We need the minus sign. Listen carefully. When it comes to distance formula, throw away the minus signs. Because we're squaring always, it's always going to get rid of the minus sign. The minus sign will only help you get it wrong on the calculator. If you put it into the calculator without that bracket drawn there, it will give minus 36 as the answer, not 36 when you square it, because it will square the 6 and then it will have the minus sign without the brackets. It's a common mistake. Best things to do is to throw the minus sign away, and we can see that this is going to be, that's 2. This is going to give us 4 plus 36, which is going to give us root 40, which is 2 root 10.
What the triangle supposed to be in the first one? The difference is 4.
Oh, the difference is 4. I didn't make a mistake. I see it. I'm still making mistakes. This is 4. Sorry. I was right first time. This is going to be 16 plus 36, which is 52. What's that in simplest form? Two root 15. So 52, halve it, you get 26. Halve it again, you get 13. You've had two lots of 2, which we can take out. So that is going to be, sorry, this is what we're doing in our head when we do this. So these bits is what the thought process in your head tends to go. You sort of just trying to.
How did you get the difference? So 1 is -4 is 4, but then if you.
So the difference is here. We're going from -1 to 3, which is +4, and from here to here, which is -6. Two more questions only. Sorry.
How come it's 2? If it's 2 times 2, doesn't it mean it's 4 on the outside?
Yeah.
What's the square root for?
2.
So that would be square root 4, square root 13, 2 root 13. Okay. All right, we move on. Our main problem for today, so this is the standard procedure, finding the distance, nice and easy. We need to do some problem solving questions. So one of the best intro problem solving questions is, what is the shortest distance from a point to a line? So the question would look like this. We've got a line drawn, we've got a point here. What's the shortest distance? The way that we solve this problem, I'm going to solve it on the next page, but I'm just going to show you how we solve it so you can follow through a little quicker. So the way we solve this problem is we need to find the slope of this line. So we find the gradient here. We can use that to find the perpendicular slope and put an equation of a line through here so that it is perpendicular to that one. If it's perpendicular to that one, that will give us the shortest distance. So the shortest distance always is going to lie on the perpendicular. Any other sort of direction that we draw like this, which isn't perpendicular, is going to give a longer line because it's a right angle triangle. You can see it from Pythagoras' theorem. This is a right angle triangle, which is the longest side, the hypotenuse. So that one is always shorter. So once we've found the perpendicular, we can find the point of intersection. So we have to find where these two lines cross next. We find this point. Then we can use the distance formula to measure this length. That is what I'm going to do algebraically. So first up, we've got find this problem. So what do we need to do first?
So we need to rearrange this as y equals. Or I don't know, we need to find the gradient.
Yeah, we're going to find the gradient. What would the gradient be? No. No. Yeah. So the gradient will be, we'll call that gradient 1. This means that the perpendicular gradient is going to be what? 3. While we're doing that, so now we've got the perpendicular gradient, we need to get the equation of the perpendicular. We're going to go for the equation of the perpendicular. We have the point it goes through, and we have the slope. Which form of the straight line equation should we use to do this? Point slope form. So we've got y minus, what's the y value? So we make plus 3 is equal to 3 bracket x minus 2.
Isn't it -1/3 as the slope? Like as a.
No, because that minus 1/3 is the slope of that line. And we're trying to find a perpendicular line. Coming back to the minus 1/3 is the slope of this line. So this one is m equals minus 1/3, and this one here is m equals 3. So at the moment, we're trying to create this line there through that point with this gradient. So we've come to this point. I'm going to expand a little bit. We get y equals 3x minus 6 minus 9. What do we do next? So what we're going to do is we're going to find the point of intersection. I'm just going to grab this one from up here. Looking at, yeah. So here, this is the other one, the other equation. So I'm going to make an equation system. what I'm going to do, and we're going to go for the x over y. I'm going to take this equation, and for the sake of solving it, the next step, I'm going to multiply by 3. I'm choosing 3 because if you notice here, we've got 3y there. We've got 3y there. So my equation solving technique here is I'm going to make this one 3y equals 9x minus 27. I'm going to take that one, which is 3y equals minus x plus 13. So now I have, this is the perpendicular, and the bottom one here, so sorry, for the video's sake. So this is the perpendicular line that I'm working with, and this is the line that's given in the question here. I can solve this equation system by subtracting one equation from the other, and the y's will disappear. So I'm going to take this equation at the top, and I'm going to subtract the second equation. So subtracting the equations is going to give us 0, 9 minus 1, 10x, minus 27 minus 13, minus 40. I think you can see the solution there for x. X equals 4. And then we can find the solution for y. We've got x equals 4. If I stick it into that one, 4 times 3 is 12. Minus 9 is giving us 3. So what we've got now, going back to the diagram, the coordinates of this point is 4, 3. So we found the point of intersection, we have the point, and we just need the distance.
Wait, you kind of lost me when you were getting the y. How'd you find the y?
So we did our equation system, subtracted one from the other, simplify, we got x equal to 4. You take 4, and look at, you can stick it into any of these equations to get your x. I chose that particular point because it's set up as y equals, it's a formula. So 3 times 4 gives 12, minus 9 gives 3.
Sorry, I was confused on where you left the 9, the 27, and the 9.
So this second equation, so take that one off. So this equation here is the same as that equation, but everything's times by 3.
Why did you multiply?
I chose to times it by 3 because I saw I was going to be lining it up with that one, which already has a 3y in it. I can choose to multiply x or y to line up either of them. If any of them are already lined up, just go for it there.
No, minus 113.
So
Plus 13.
I just rearranged that one slightly as I moved it across so they lined up quickly. All right, finishing the question off, we have that the distance now is going to be the change in x and the change in y. So let me just put up my 2 points. I've got 2, minus 3 is the given point, and then I've got 4, 3. Popping these into the distance formula gives us, what is the change in x? 2, so that's 4. What is the change in x? That's 36. So this is root 40, 2 root 10. That's our answer. Let me take the attendance quickly while you guys, I can just pause the video as well. Where's my video? Okay, so you should have got about this far as you worked on it on your own. Let me just run through what I'm doing here. Let me just get a little bit of a pen to do some highlighting so you can hear on the video where I'm pointing. So we start off by looking at the coordinates of AB, and we calculate the gradient of AB. That's at minus a quarter. We take that, and I'm taking this point here, and I'm taking minus a quarter as the gradient, putting it into point slope form, and I get this equation here. Then I don't need this equation here. I'm going to need it later. I know that later I have to find the point of intersection. So in order to find the point of intersection of these two, I'm
divided by 17.
Okay, so reviewing the problem, we find the gradient of the line AB. We find the equation of the line AB. I'm going to be doing an equation system later, so I'm just expanding that. To do the expansion for this, what I want to do is I want to get rid of that 4 in the denominator there. I take that 4 and I multiply it through the whole equation, which is why this increases by a factor of 4 and this increases. Look here. I'm increasing these by a factor of 4 as I move that 4 across. The minus 1 I'm not moving, so the minus 1 I just expand into the bracket. And that gives me equation number 1, which is x plus 4y plus 10. Great. Next up, I'm after my perpendicular. So I find my perpendicular gradient, which is the negative reciprocal, gives us 4, the negative reciprocal minus a quarter. I then use the point C, which is down here, 1 comma minus 3, and I use point slope point. So I put the minus 3 in here, put the gradient of 4 there, and I put the 1 in there. And it gives me an equation, second equation. Expand the bracket, 4 times x gives 4, 4 times minus 1 gives minus 4, subtract 3 gives minus 7. So then I just rearrange it into this form. I get equation number 2. So if you look at equation number 1 and look at equation number 2, I'm looking for a simple method to eliminate them. The 1 and the 4, none of the coefficients of x and y are the same. If they were the same, I go for that. If there's a simple multiplication, then I go for that. So what I see now is I'm going to multiply equation number 2 by 4 to give me this form. It's still equation number 2, that one. I've just multiplied everything by a factor of 4. The reason I've done this is these are going to line up and cancel. So these can cancel if I add the equations together. I add equation 1 to equation 2, so we get x plus 16x will give me 17x. I get 4y plus negative 4y will give me 0, the y's disappear, and then I add the numbers together. This gives me an x value here of 38 over 17. Now, what is the domain of the line segment? What is the domain of the line segment? Negative 2 to 2. Is this number bigger than 2?
No.
What's 17 times by 2?
It's 2 and
It's
4,
2
7.
point.
So 34 over 17 is 2. So this is bigger than 2.
It's 2.2.
What does that mean?
That means the differential size is not on the
No.
It doesn't.
There's no triangle.
It will intersect with line number 1, but line number 1 is a line. That's not the line segment. The line segment is the same equation, but then with the domain specified. So you could specify a line segment by giving the equation of the line and then saying the domain is minus 2 to 2. So what we have here is we've drawn our perpendicular. We're trying to solve the problem. But the problem is our perpendicular goes up like this, and it crosses this line over, well, it's not quite right, but a little bit closer, so like that. So we can't use this one. But we still need to do this because we didn't really know by looking whether it was going to miss or not. It was quite close. So now we need to find the distance from C to B. B is going to be the closest point. So instead of using the perpendicular, this will give us the closest. So we put this into our distance formula, and it gives us distance is equal to the square root of, what is the change in x here? 1. What is the change in y? 5. So that's going to give us root 26. That's the shortest distance. Yes.
I have a question. So when you were combining the two equations, like x plus 4y, how did you get to 16x?
I times everything by 4.
Oh.
Because I want to get to minus 4y. I want to get to minus 4. I don't care about the others. I want to get to minus 4y, so I times by 4. So that when I add them, they cancel.
Do you simplify 26 now?
No, 26 is the 2 13. That's why no.
Can't you do 25 and 1?
No.
Just 5 and 5.
No.
The x equals to 38 divided over 17. That's the intersection point between lines AB.
Yeah, so this x value here, 38 over 17, is the intersection between the perpendicular to AB that passes through C and the line that passes through AB. What we find the intersection, it's about here that they're intersecting. We don't need the y value because with this problem, when you get the x value, you should check if the x value is in the domain of the line segment. Now the domain of the line segment is from -2 to 2. This is bigger than 2. We see that this is bigger than 2 because 2 times 17 is 34. So 34 over 17 is 2. Any number on the numerator then bigger than 34 is bigger than 2. And we spot it like that.
So there's no need to find the y.
There's no need to find the y. There's no need to find the y.
And x plus 4y equals 7, how did you get that?
X plus,
4y equals 7.
that's the equation of line AB. That's the equation of line.
Couldn't we also like do it instead of doing the system with couldn't we just like times like make them equal to each other? So
Make what equal to
the two the two line formula. So it would be like 10 minus x equals 4 times 4 minus 7.
Okay. So that is a system of equation system. You're using a different equation system solving technique to solve the equation. It's still something the same answer. Doesn't matter. At this particular point, so for this problem, there are other ways. You can see this method is going to get you through to the solution on this one. There are other methods as well. There are other methods. So for instance, this is one method of solving the problem. You can do radically different methods of solving the problem. So you've got the same information. You could calculate whether this angle is acute, obtuse, or right angle. So if that angle there was obtuse, meaning it's more than 90 degrees, the angle between this point, the line CB and the line AB, if this is obtuse, it means that you're going to find the shortest distance from C to A. If it is right-angled, the shortest distance is from C to A. And if it's acute angle, not right-angled, and this, you'd have to check this one because obviously it swings all the way over here. But if you can see that it looks like it's going to be close to that one. If it's an acute angle, it means you need to use this method all the way through. So you can do it by identifying whether the angle is acute or obtuse or not, and classifying it. Because you've got three basic problems here. When you're looking for the distance from a point to a line segment, you're either going to draw the perpendicular line and it crosses, you're either going to draw the perpendicular line and it crosses at B, that's the right angle, or you draw the perpendicular line and it misses, that's the obtuse angle. So one of those three. You can identify that fairly quickly using the Pythagorean inequality theorem. So you take Pythagoras' theorem and then basically turn it into an inequality. So you're taking c squared, a squared, and b squared. So if c squared is less than a squared plus b squared, it's acute. If they're equal, it's right. And if it's greater, it's obtuse. You can use this theorem to solve other problems too. There are multiple ways to solve the problems. These are a couple of the introductory ones. And then lastly for today, classifying triangles. So just to finish off, we can classify a triangle by its size. Triangles can be classified by their size in three ways. Classified, it can be an acute triangle, an obtuse triangle, or a right angle triangle.
Is this proof that we have to write it?
No. We're just investigating and finding an answer. So what you can do is you can use the previous Pythagorean inequality theorem to decide what type of triangle that is. So have a go at doing that question now. But you have to decide which one's going to be your A, B, or your C. So you can see the You can have a go at that one. If you find the length of AB, the length of BC, and the length of AC, find the length of each using the distance point. Find the three lengths of the sides of the triangle. Stick it into Pythagoras' theorem. The longest length, obviously, is the one you're sticking into C squared. Yeah. But in this concept, you can't specify they have to be facts. So they have to be positive. Yeah.
That's okay.
Okay, that's finishing us for today. There's a worksheet to finish on the classroom. I'll post the slides and the video from today's lecture for you on the Google Classroom.